This video focuses on for loops in Java, and we're going to see that they're very different from for loops in Python. Before we do that, though, I want to talk about shortcut operators. So consider this short piece of code in Python. We assign the value 2 to the variable result. We assign the value 5 to the variable n. We then update the value of result to be the product of its original value times the value of n. Then we update the value of n to be one more than its original value. So here's the corresponding Java code fragment. Again, this would need to be in a method and in a class, but this is just the fragment itself. And you can see we need semicolons at the end of the assignment statements. We also need to declare the variables the very first time that we encounter them. So they're pretty similar. And when it comes to shortcut operators, we've seen that Python has these operators that allow us to combine arithmetic operations like addition and subtraction and multiplication with assignment. For example, this line of code here, we can replace that with one that uses the shortcut operator times equals. And that's equivalent to what we had before. And then here we can use Python's plus equals operator to simplify that line of code. Java has the same shortcut operators that Python does. So up here in our third and fourth lines, we can use them to simplify things. But Java also has two special shortcut operators that are not in Python. The plus plus operator can be used to add 1 to the current value of a variable. So if I say x plus plus, that's the same as saying x is assigned x plus 1. The minus minus operator subtracts 1 from the current value of a variable. So x minus minus is the same as x is assigned x minus 1. And so up here on our fourth line, rather than using the plus equals to add 1 to n, we can instead use plus plus. So here's an example of using a for loop in Python. We pass in a value to this function fac, and the value we're passing in is some integer n, and it's going to return the factorial of n. So it has to compute that factorial. It does so by first initializing a result variable to 1, and then it uses a for loop to compute using a cumulative computation the factorial of n. So x is going to take on every integer from 2 up to n. Notice that we have to say n plus 1 because range goes from its first value up to but not including the second value. So for every integer from 2 to n, we're going to multiply that value of x by the current value of the result, and we will gradually accumulate the factorial. And then once the loop is done, we return the final result. Here is the corresponding Java static method. And if you look at the for loop, you can see it looks very different from a for loop in Python. So every Java for loop begins with the keyword for. And then typically we have 3 components in parentheses separated by semicolons. The first component is the initialization. So in the case of our for loop, we start by initializing a variable x to 2. Then we have what's called a continuation test, and we evaluate that test to see if we should execute the body. If the test is true, we execute the body. If the test is false, the loop is over. So after doing the continuation test, if it's true, we'll do the body once, and then we go and do what's called the update. And in this case, we're saying that we want to increment x by 1. And we're going to keep doing test body update until the test is false. So we can see that more clearly by looking at this flowchart. So we always start by doing the initialization, and it's only done once at the very beginning of the loop. We then look at our continuation test to see if it's true. If it is, we execute the body once. Then we go and do the update, whatever is in that third component of the header. Then we go back and do the test again. If it's still true, we do the body and then the update. And so we're going to keep doing test body update until the test is false, at which point the loop is over, and we go and we skip over the body And we come down here and do whatever statement comes after the loop. So let's actually trace through the loop in our factorial function. So to do that, let's assume that we're computing fac5. So we're passing in 5 for n. We then initialize our result variable to 1, and I'm going to keep track of some of the key components here in this table. So result is now 1, and then we begin our for loop. And let's focus on that. Let's highlight it by pulling it up here, and we're also going to have a flowchart which shows how all of the components correspond to that generic flowchart on the previous slide. So again, we start with the initialization, which is x is assigned 2. It gets done at the very beginning, but never again. Then we look at our test. In this case, the test is x less than or equal to n, and because n is 5, it's x less than or equal to 5. And that is indeed true here, because 2 is less than or equal to 5, and therefore we're going to execute the body the first time. And result becomes 2, because we're saying result times equals x. X is now 2. 1 times 2 gives me 2. Then we go and do the update. So this is the first time we're doing this third component, right? So it was initialization, test, body, update. And update is just saying increment x by 1, so it's now 3. Then we do the test a second time, right? Because after the update, the flowchart says go back up to your test. And the test is still true, so we do the body a second time. 2 times 3 is 6, and so that's our new value of result. We update x to be 4. We do our test again. It's still true, so we do our body again. 6 times 4 is 24. That's the new result. We update x to 5. Test again, still true. Body gives us 120 for result. We update x again. So x is now 6, and this time when we do our test, because 6 is not less than or equal to 5, the test is false, and therefore the loop is done, and we go to whatever comes after the loop. In this function, this static method, what comes after the loop is our return statement, and so we're going to return 120, which is the final value of result, and that is indeed 5 factorial.